Okay, the PPT is visible, right?
Yeah.
Okay. Okay, guys. So the theme for this month is humanoid robots, and the first session, as always, would be just exploring humanoid robots, and we would be discussing different kinds of humanoid robots that are used in industry and research. So this one you can see the one by Boston Dynamics, the Atlas robot. We'll just have a look at different kinds of robots that are existing, and in the coming sessions then we will take one of these robots as a case study and reverse engineer them or deconstruct them like we do with the like we did in the previous sessions, right? So this is how we'll go about it today, and the idea would be that after discussion maybe we'll also make a mind map. Yeah, depends on how it goes. Let's see. Yeah, so the agenda is I didn't update it, so it's not correct. Yeah, again, to just briefly mention, we are an active learning group of robotics and AI enthusiasts, and we learn by taking up several real world case studies and projects, and try to then go from a top approach to the very core fundamental concepts in a way. And anyone is actually open to participate, especially for the first session, because it's more general and we don't discuss much of technical details. And the first session, by the way, is more interactive, and anyone can participate, and it is not supposed to be a presentation by me. It's supposed to be a discussion. So if I share a video, and we can discuss about it. If you know more about that, we you could feel free to share that, basically. And again, so I'm not actively looking at the volunteer roles. At some point, I guess I have to manage it. I mean, the plan was that we would make the research paper reading thing and Ross tutorial presentation also more regular, but yeah, I guess it would take a while. So let's start with humanoid robots, and first of all, yeah, these are just like this is just a list of a few popular humanoid robots that are existing in the industry, and we'll begin by just watching videos of some of these robots, and then we will discuss about it, and we'll also talk about what existing repositories are there, what open source projects can be done in the space of humanoid robots, which would be interesting. And at any point, feel free to share if you know some other interesting projects that can be done, or some other existing products that are in the industry. And in this list is of course in no way comprehensive, right? So I mean the best way to start would be to take a very small clip by Boston Dynamics, right? 2 months ago they did this demonstration where Atlas is shown to perform parkour, so which is pretty interesting. So now I'll do a stream, so you can also probably listen to the audio, right? Just let me know if it works, if the sound works. Is it is the sound audible?
Yeah.
Okay. I mean, in this video though, it doesn't matter because it's just background. I mean, with these videos, you can't really trust these videos because these are more for demonstration, right? But it definitely shows that the hardware and the control capabilities are there to allow the robots to do these things. Of course, the robot is not sensing the environment and it's not autonomous in any way, right? In these demonstrations, what are your thoughts on this? You probably have seen this video, right? Several times. How many have seen it though?
Yeah, I have seen this one.
Yeah, yeah, yeah. It's of course. I think most of you have already seen it. It's pretty popular. But yeah, again, like, uh, yeah, it's just mostly for demonstration purposes.
Yeah, but I am more excited about the bot from Tesla because the shape is not nearly looking as this one, and I don't know how
Yeah,
will they balance everything, including the hardware and software. Maybe they are doing the processing on some other machine remotely and using only the motors to run that thing. I mean, that is also doable, but in the future, if you want to go to autonomous and in that form factor, it sounds difficult, but why would anyone, approach it like human? You can do something like this as well. But yeah, let's see.
I mean, so in the I watched some portion of that talk by
Hmm.
Elon Musk, and he said that since we already have the computer vision technology, and so we just want to transfer that to a different hardware in a more humanoid form. So that was the idea, and actually we do have. Since we're
That
talking about Tesla bot, we can just go to that, right? It's yeah. So these are just I've taken screenshots from that live event, right?
right.
So this is just the primary specifications, and then the technical. We have a screen here, and then of course they're using lightweight materials,
I
and
think you are on YouTube
okay,
on this
yeah,
one.
yeah,
Yeah.
yeah, yeah. It's always the
I
thing
mean,
with
you
this
can
one.
do full screen share, but it's your wish.
Yeah, yeah, yeah. Now I think should be fine, right? Can you see the Tesla bots?
Yeah,
Yeah.
yeah.
Yeah, so this one I was talking about it. This is just basic. What it's supposed to be doing is it would be eliminating the dangerous tasks and maybe also in household. Not sure which applications he would be targeting at this point. The demonstration video though was the demonstration was a bit funny. I mean, there was a dancer that played the role of the Tesla bot, which was.
Yeah, I mean, it was lame.
It was like it
I
was
mean,
funny.
I will not say it was funny. It was pretty lame
Yeah,
coming
I don't
from
know.
such a big company.
Yeah, that was unexpected. That was unexpected. I mean, they didn't need to do that. They didn't need to do that.
And the guy that was performing that, he could be an engineer. Who knows? He could be someone who is working. I don't think he's a hired artist or something.
Yeah, yeah, yeah. Anyway, yeah, that was his Elon style of demonstrating it. So yeah, you see here the technical details that they shared is they're using lightweight materials, and this one is also like very top level and not too detailed, right? Force feedback sensing and two axis feet for balancing. It's just a concept. I don't think they have anything ready at this point. And then
Yeah,
autopilot
and this
cameras and
this will this will take them a lot of time because other companies like Honda, the
yeah.
Osimo bot, I think it is still under development if I'm not wrong, and they have been doing that like from 1990s, I guess.
Yeah,
Uh,
yeah.
and it was at the start it was a huge robot, and then they scaled it down for representation.
Yeah, I think a part of the reason would also be because we want the humanoids to be not intimidating, right, to humans. So they
Yeah.
have to keep it in a, yeah, keep the,
And the height which Elon chose for this robot is like is 5'8".
yeah.
So so this is I mean this is on the average human height, but it is above average, I would say. I mean, 5'8" is pretty above average.
Yeah,
And
it's the normal height, yeah, average human height. So
yeah, let's see how does it do this.
yeah, and then they have a computer. I'm pretty sure they would probably be updating this as they actually do the prototyping and development of it, and multi-camera video neural networks, neural net planning, auto labeling. Yeah, I think this is just like very crude
Hmm,
this
correct.
point. Yeah. So Atlas, we saw Atlas. We can see some technical specs of Atlas and all, right? Atlas specifications, Boston Dynamics. Yeah, it's the article about the parkour. The control software uses the whole body, including legs, arms, and torso. hmm Atlas is designed to, yeah, this is just entered into a two-stage control problem, a behavior level control that outputs high-level commands, and a low-level controller that is responsible for generating joint commands. Yeah. In order to fully utilize the workspace and be robust to external perturbations, the low-level controller has to take full body kinematics and dynamics into consideration. Yeah, so here they've talked more about this control part. So walking, full body manipulation, traverse door control. This looks like a good article. I didn't see it before. Maybe I'll add a link to this in the PPT, right? I'll share this. So here is the specification of this. This is a bigger one, right? It's 1.88 meters. Yeah, but also the thing with Boston Dynamics robots are that they're more research oriented, right? Uh, they try to expand the possibilities with these robots. So it's pretty cool. I've added this to the reference as well. Now, by the way, like I think Volver has really good content on their website as well about robotics. I think they're more general, right? They have IoT and other stuff as well. Anyway, guess.
Oh, Revolver covers robotics as in general.
No, I think they're general engineering, so robotics, autonomous vehicles, AI, 3D printing,
Oh, okay.
IoT, and everything.
Earlier I was thinking they were a social media company because they had liked some of my comments on LinkedIn, and I was thinking, why are they liking? Is it a bot or something? And some of your posts as well on building culture and your personal LinkedIn.
Yeah. I've noticed that too. They're a content company. I think they write these articles and create these content, this such
Yeah.
sort of content. But yeah, it's good. It's good quality there. Yeah, the most dynamic humanoid robot. And, so I think the main strength of Atlas is the control system that they have. Right, we could take up. this as a case study potentially. Let's see. The model predictive control is what they're using. Resources, yeah, you can check this out in detail. Okay, and let's move to yeah. Any comments you want to make or anything? Just feel free to add anyone else also. So, Yuan, Dennis, if you want to add something or share something. Sure, he can't even hear us. I don't know, but yeah. Yuan, any one of you guys want to add something, or shall we check out another robot? We have quite a few today. Okay. Yeah, sorry, you were adding something?
Was about to say that we can continue.
Okay. Okay, perfect. So the other one is Now and Pepper by SoftBank Robotics, right? So let's just open SoftBank Robotics website itself. Pepper, Now, these are the two humanoid ones. Yeah, so these are like more these are more applicable in social settings, right? So the application is different. The Atlas one was, yeah, it was more for research purposes and to actually see what the robots are physically capable of doing, and these are focusing on human robot interaction primarily. And yeah, have you guys seen? You probably, some of you have seen Pepper in real as well, right? If you attend some conferences or some, so yeah, you would see Pepper.
Yeah, I've seen it.
Sorry?
I've seen it, yeah.
Yeah. It's pretty common, this one. And then there's Now. This one is also is a bit smaller one. Oh, they have a nice 360-degree view here. Yes, so let me see. Yeah, so let's check what features that they have, right? So 20 degrees of freedom for natural and expressive movement. So it's wheeled at the bottom, right? At the bottom it's wheeled, and overall it has 20 degrees of freedom. So and speech recognition, and I think this is the main thing, because its goal is to interact with humans and guide them in different areas, and maybe as receptionist or as showing around a store and these kinds of applications, and perception modules to recognize and interact with people. I think what would be interesting is if we can find like a detailed spec also right here at the bottom. Open and fully programmable platform, yeah. Let's see, industry.
Is the back wheel a caster? If I'm not wrong.
Let's see the specs. Well, let's watch the video. I'm pretty sure we'll find the specs as well, right? Let's watch a small video to get the applications. So the sound is just music, right? So I think we can go with it. Go without the music.
I personally think the temperature scanning was the best use case ever for this one.
Temperature scanning, you think is the best feature
Best
that.
one, yeah,
Hmm.
because it's quite repetitive at malls, and the sometimes the people the staff there also tells us to wear our mask if we aren't. So the facial recognition with the mask is also good feature.
Yeah, yeah, yeah. Yeah, they're used in retail stores. I'm trying to see now the specifications, which would be more interesting, right? Typical use cases are receptionist and welcome assistant, sales assistant. Yes, all these. Hmm. I'm not sure. I think for that, I guess you have to, yeah, contact them, I guess, to get the brochure. But let's
I think
see.
another use case could be if you need to navigate a room in an office or in a hospital. That could be a good. I mean, you can just follow the robot.
Yeah, yeah.
It's
I think it's still. I mean, I think Pepper is used for
is
these.
doing that.
I think so.
Is
I
it
think.
doing that?
I think so.
Is
I'm
it?
not sure, but yeah, yeah, that's definitely a practical use case. Technical specifications, soft. Oh, here coming soon. Really.
I
Uh,
mean, yeah, they would not, release all the specifications and
yeah,
the
yeah,
electronics that easily.
yeah.
And
But like
even if,
just overview. The top level stuff.
yeah, and they usually rename such stuff. I mean, they will just name, the brain as the computer or some model version computer of their in their own language.
Hmm.
They will not list out all the small parts
Yeah,
because
yeah.
uh, because then everything will be open source.
That is generally would be in service modules, right? So it is chargeable here and user guide certification. Yeah, these are just wins unbox Pepper. Ah, let's see. So here there's like really no sound at all. So so here at the bottom we have the charging slot. Let's see if we have more details. Do you think a tablet is needed for this kind, or do you have do you think another sort of a user interface could be used for this kind of a service robot in retails, these applications. What are your views on this user interface?
I mean, they are showing that it's an Android tablet, and it probably is connected to some sort of firmware with the robot.
Yeah.
I think this is the best UI this robot can give at this point. I mean, you wouldn't go back to the tactile keyboard stuff. I mean, that would be pretty tedious to do that on, but since it's touch screen and it's a screen, I think it's the best thing.
I mean, people are familiar with the tablets, right? I mean, I'm not talking about keyboard versus tablet, but rather using a tablet or going without the tablet, and even just speech driven, or maybe just a little text, or LCD tracker, or something like that, and mainly relying on voice. I think the voice is not still fully reliable, right? So that's also the reason that tablet is a good idea.
Because we will need to use some sort of machine learning to sense and analyze what the other person is talking about. I mean, at this point, I don't think they are using speech recognition to understand what the user wants, and that same thing is being done by the tablet.
Yeah. Eventually, I think they would as the technology also progresses, right? As NLP becomes more reliable, I guess. Yeah, but let's see. And then we have environment sensors inside the bumpers, the microphones, okay, and cameras. Yeah, it's a smaller one, right? So it makes sense that the microphones are on top when someone is speaking. And then there's cameras. And then speakers, and it's wheels, I think 3 wheels, right? Caster type or not, I think it would be caster type. And then the charging flap. Okay. Yeah, you could play it in simulation at least, right? I'm not sure if you would be buying it, so.
But do you have also an application for your mobile phone to control Pepper?
I think so, yeah, I think so. Install or create applications to customize your Pepper. Yeah. So I think installing an application.
Yeah.
But how customizability they're offering, I think that's also a thing to see. Downloads software. Yeah, this is the software development kit. Charging station per user guide. I think here we'll actually probably see more details about this stuff. Maybe also about the software capabilities. Soft cover and soft button, shoulder LEDs. Yeah, these are the hardware things.
I think they should also try swarm peppers. I mean, multiple peppers connected to each other.
Maybe, let's see. Swarm of pepper robots.
Yeah. No, I don't think it's still there.
Yeah, I don't think so either. But I'm pretty sure they would also be thinking about this, right? But for what application are you do you think a swarm of Pepper robots would make sense?
Maybe in some there is no uh, I mean the one can think of a use case that is beneficial for us, but if you want them to make them dance some particular thing like uh,
So just for
Boston
like
Dynamics did, yeah, just for
entertainment
fun,
and yeah,
yeah,
okay.
just for entertainment, yeah. I
Hmm.
mean, since they are like really small in terms of form factor, it would also look cute. So
Yeah.
there's that, yeah.
Mm-hmm. I mean, for example, for retails, maybe a couple of 2 or 3 robots, or depending on the size, uh,
Yeah.
that would be sufficient. But yeah, depends on the
Or
application.
maybe on tours. I mean, if you travel to some other country
Yeah,
for,
that's good one.
uh,
Yeah.
I mean, if you want to go on tours on your foot, so you can use multiple robots. So you can divide them into smaller groups, and then you can view the entire city from different angles, and the whole group can meet together in one place using the robots.
I think with museum
Yeah,
as
museum
museum
visits.
guides, it makes sense.
Yeah, with museum guides or even monuments or some other places,
Hmm.
this would be used. Yeah.
Yeah. So these are just details. Very choosing the location for safety ensure. Yeah, it's also the limitation is it has to be like flat and ensure there is at least 90 centimeter around pepper. Ensure pepper is on a smooth and flat surface. Avoid rugs or carpets. Yeah. So it's a very practical robot. I mean, they're focusing only on the things that are needed for service robots, right, and not uh, adding unnecessary features. Talking with Pepper. Pepper is not able to talk unless the appropriate software is installed. Pepper is listening when Pepper looks at you. Okay. Do not speak at the same time. Use short sentences. Do not speak too fast. The shoulder LEDs notify the user of new information. The colors of the notifications indicate the type of information. Ah, to listen to notification. Briefly press the chest button once to listen to the notification. Then there's sleep mode. Rest mode and turning Pepper off. Okay. Yeah, I think apart from that, it's just safety information. Laser and infrared information. Lasers and infrared sensors help Pepper to interact safely with the environment. So, so sensor ranges are also defined here, right? 3D sensor detection range, and then sonar detection zones, infrared detection zones, infrared. Where is infrared detection? Oh. Can you? Okay, here, this one, right? Yeah. Infrared detection zones, laser and sensor detection zones. Blind. Yeah, okay. Okay, anyone wants to share something about Pepper, or then we can now check the Now robot, right? No. So here, this one has more degrees of freedom because it's, yeah, there's It's a legged robot and 7 touch sensors located. It's a fundamentally different robot than that. Look, 7 touch sensors located on head, hand, and feet, sonars, and an inertial unit to perceive its environment. 4 directional microphones and speakers to interact with humans. Speech recognition is again the primary. In 2D cameras to recognize shapes, objects, and even people. Okay, I'll just so lithium ion batteries are used, and we have loudspeakers are at these locations. Then 4 microphones we have, right? I mean, what would also be interesting if we have some repositories on GitHub for this basically. So now robot. Has anyone worked with this robot in simulation even? No. Okay, let's watch this.
Hello now.
Hello. Give me this ball, please. Nice ball.
I'm sorry. Are you all right?
That's okay.
Okay.
Yeah. What I was checking was the cost of it actually. Uh, so we have to check on the official. I mean, yeah, you have to get a quote, right? Does anyone have any idea about what's the range of now robot? Price upon request. Yeah, here it is. 7990 is offering down from $16,000.
It honestly doesn't feel so. I mean,
Doesn't?
looking at it, it doesn't feel so. It's like this costly.
Uh, I mean, yeah. It's smaller, but it's still, I mean, it has a lot of voice features, and I mean, of course, it's costly, right? It's
Yeah.
it has
I
a lot
mean,
of
if
joints
this
and
is
moving
costly,
parts also. So
yeah, if this is costly, then how much will be the last one?
pepper, yeah,
Uh,
yeah, we
the
can.
pepper one. Yeah, the pepper.
The price of
See,
pepper is
this
about,
one is lower.
but it's probably, yeah. I mean, these robots are then bought in bulk, I guess, and probably now can be bought individually. I'm not sure though. So for the first time, we'll be able to purchase in the US. Yeah, but it's $1,800 and now is more costly
More
actually.
costly, yeah.
Interesting.
And pepper does more than now in
Hmm.
terms of use cases and
Yeah, that's a good observation here, right?
are they both related? I mean,
They're
the
f-
parent.
they're from SoftBank Robotics, both of these.
Are they both of them?
Yeah,
Okay.
yeah, yeah.
Okay, so like SoftBank is their parent company.
Exactly.
Then why is the one that is smaller costlier than the one is? I mean,
I think it the reason would be it requires precision, right? The smaller components,
yeah.
it requires
Okay.
manufacturing of more precise components. I think the software side would be more or less similar, right? Yeah, so that's what makes sense right now. But yeah, that's a good question as well. Let's see what we have here.
I know.
Hi, Paul. How are you today?
Fine, thanks. Are you ready to do some work this morning?
Sure.
You say you love me. No, you say you love me. No, you say you love me.
I mean, so with pepper, I mean, They do have movable finger joints as well, right? Yeah, but here, I think the logical reason that I understand is because of manufacturing of precision, the requirement of precision for these smaller components. But yeah, what do you guys think? Why do you think the cost of now robot is greater than Pepper one? This is an interesting question. Okay, yeah, we'll see that anyway after this video.
No, you say you love me. No, you say
Catch
you
it.
love me. No, you say you love me.
There is a web
Too
page,
easy, my friend.
SoftBank Robotics website.
Mm-hmm.
It says that Pepper costs 20k euros and now is costs at 7k euros.
Okay.
So I think that I mean the ones that was shown in that website, they were wrong.
Okay.
Yeah, I've sent the link in the chat room.
Let's see.
I mean, you can compare other features like
you found, yeah, this is exactly what I was looking for. Yeah.
now lacks 3D vision and emotion engine. And
Yeah.
that's pretty much it. I mean, for
So
for
it's
those
20k euro it says, right? So this is here
Yeah.
it's expensive. So so why did that say like maybe that was
I mean,
wrong?
maybe they revealed the price to research on that. I mean, $7,600 or euros, I don't know. It probably is the amount that you require for researching, prototyping one thing.
So they say at around $1,600 per robot, 10,000 robots equate to $16 million sales in Pepper are sold on a subscription contract that includes a network data plan and equipment insurance. This costs 360. Yeah, so it's a different plan also, right? They're not selling it directly. It's a subscription based service that they're offering with Pepper.
Yeah.
Yeah. So yeah, I think if you were to buy it, it costs this much. So yeah, then it makes sense. Then it makes sense. But generally, I guess they're offering then this on a subscription basis.
Yeah. And interestingly, now has more languages than Pepper.
The applications are different. It's now is more for can be used in household and office settings, whereas this is supposed to be providing information in retail stores and all, right?
Yeah.
So it says, height wise we know the difference. Autonomy, 12 hours it can last. It can just last 1 hour. It has more languages. Yeah, it has offers more languages. It is more, I guess, for educational purposes now is more suited, right? And it doesn't have 3D vision and emotion engine.
Yeah.
Yes. Yeah, this is the exact link that we wanted to see. Yeah, thanks for sharing that. Yeah.
Come here.
You say you love me.
Try again.
That's not really funny.
You say you love me.
Yeah, okay, let's move to another one now, right? We saw these four now. Let's go to iCub first, right? Let's go to iCub and Osimo then, and then we will go to the really human looking ones, Geminoids. I guess let's just watch on YouTube, right? And I'll now turn the stream on so you can also listen to the sound, right? Yeah, let's watch this. I think there would also be they would be explaining stuff also here, so.
Robotic robot has, through its shared memory, already attended thousands of emergencies, like fires or cardiac arrests, that it's made millions of cups of coffee, driven thousands of miles in every make of car, or walked every breed of dog on the planet. There's a theory that it takes a human 10,000 hours to master a new skill. Well, robots could come with 1 million times that competence.
Yeah, this was a good informative video, right? iCub is like one of those, you know, the dolls you see in scary movies, right? It's a bit visually it can be a bit creepy at times. And I think the research there with iCub is mostly using imitation learning and reinforcement learning and vision for these everyday tasks, which is pretty interesting. So this is, I think, like learning from demonstration sort of an approach, right? Yeah, the person is actually demonstrating it, and then it just learns using that data and then repeats the process. Or yeah, I'm just assuming. I don't know what they are exactly doing, but it looks like it. Okay, let's see. So iCub is actually by IIT, not the IITs in India, right? The Italian Institute. Let me see. Yeah, here this one. iCub, the yet unfinished story of building a robot child. Yeah, and you could also check the publications related to the research, right? Humanoid sensing and perception. Actually, there's also one robot that I didn't include. So there's this KIT Humanoid Robot Lab H2T or something. Yeah, high performance humanoid robot. Yeah, this one also came to my mind. But yeah, first on iCub. PhD dissertations of people are also openly available here. Human robot collaboration. Anyway, yeah, just also you can check out this institute's website, right? There's, I think, a lot of really interesting stuff, interesting research that they're doing. Yeah. Okay. Yeah. Let's move to another one. Does anyone want to add something? Okay. And then there's this one also, H2T. I don't know what project they're involved in, but they're into humanoid robots research as well. So integrated humanoid grasping and manipulation, these things. Yeah, and also they have, by the way, I think research with kitchen robots as well. Let me see if I can find something here. Let me just write here, right? H2T KIT kitchen robot humanoid. Yeah, I think this would be a good one. It would be in German though, but let me see if I can add English subtitles, right?
Ein Roboter, der im Haushalt hilft. Keine Zukunftsmusik. Am Karlsruher Institut für Technologie übt Roboter Armar 3A bereits die ersten Handgriffe. Er kann sich frei in der Küche bewegen, den Kühlschrank öffnen und dem Menschen daraus eine Apfelsaftpackung bringen. Was einfach aussieht, ist technisch eine hochkomplexe Handlung. Ein Roboter, der in derselben Umgebung wie Menschen agieren soll, muss diese wie ein Mensch wahrnehmen und sich ähnlich wie ein Mensch darin bewegen können. Außerdem sollen Menschen so natürlich wie möglich mit ihm umgehen. Eine humanoide Form erleichtert das. Die Forschung an humanoiden Robotern setzt Forschung über die menschliche Kognition und die menschliche Bewegungsweise voraus. Um zum Beispiel eine Roboterhand zu bauen, die die gleichen Aufgaben ausführt wie eine menschliche Hand, müssen die Forscher genaue Kenntnisse über die Anatomie der menschlichen Hand haben. Um Algorithmen zu entwickeln, die einem Roboter erlauben, Gegenstände zu erkennen und zu greifen, müssen die Forscher verstehen, wie ein Mensch die Welt wahrnimmt. Armars Augen bestehen aus Kameras, deren Abstand dem Abstand der menschlichen Augen in etwa entspricht. Insgesamt sind es 4, 2 für die Weitsicht und 2 für die Nahsicht. So kann der Roboter den Abstand zu Hindernissen und Gegenständen berechnen und sie greifen. Er muss die verschiedenen Objekte voneinander unterscheiden und sie greifen können, ohne sie zu zerstören oder fallen zu lassen. Für eine natürliche Interaktion mit dem Menschen muss Armar die
Umgebung ausführen, zum Beispiel in der Küche. Sie können, um zum Beispiel größere Flächen zu wischen, beziehungsweise um schneller oder langsamer mal den Tisch zu wischen.
Armar 3B beobachtet den Menschen und merkt sich die Form und die Frequenz der Bewegung. Das wird dann in eigene Bewegungen umgesetzt, um den Tisch in kleinen oder großen, langsamen oder schnellen Bewegungen zu wischen. Die Roboterhand ist mit Sensoren ausgestattet. Positionssensoren messen die Fingerstellungen, Drucksensoren und taktile Sensoren liefern Kraft- und Kontaktinformationen. Mithilfe dieser Sensoren versteht der Roboter zum Beispiel, ob sich ein Objekt in der Hand befindet und ob sich dieses Objekt verformen lässt oder nicht. In Zukunft soll Armar mit Beinen ausgestattet werden, um zum Beispiel Treppen steigen zu können. An der nächsten Armar-Generation, Armar 4, arbeiten bereits die Forscher am KIT.
Uns schwebt natürlich.
Yeah, I think this one, yeah, it's interesting, but this is also an older version, right? Maybe they have a newer one as well. No. Yeah, but this was the one that I also wanted to share. I'll add this to the list, and then yeah, we can see at DLR, Osimo, and robots. What do you guys think? Is it useful that we are watching? We are having a quick look at all of these videos, or do you have any suggestions there?
Well, I think it's fine to see an overview of what is currently being developed.
Yeah, so the idea is we just have a look at what all is existing already, right? So yeah, if it gets too boring or anything, just let me know. We can also pause and discuss stuff, right? And then Osimo, you guys already know about. Let's just have a small look at this in most recent ones. It's like, not sure if they're really. Okay, this one would be the most recent one.
Hello, I'm Osimo. This is the origin of Honda, which remains unchanged since the establishment of the company. Honda is developing various products to make mobility and people's daily lives more enjoyable. In 1986, Honda started its robotics research with the goal of helping people make their daily lives better. In the beginning, even taking one step forward was very hard. There were many trials and errors. My journey began on October 31st, 2000. And I have traveled all over the world and have met so many people.
Congratulations!
Yeah, this is...
The all-new Osimo received a full model change, equipped with high-response control system and applied mechanisms that are all newly designed. Engineering innovations regarding flexibility and balance control have increased Osimo's agility, both in the upper and lower body. Stability control that was first developed as a key part of making Osimo walk autonomously has seen continuous innovation and has taken another big step forward with this new model. Osimo, are you ready to climb the stairs?
I am ready.
Okay, go for it. Some of you have likely seen Osimo climb the stairs on its website, but the latest version of the robot can ascend and descend much more smoothly without even having to stop at the base of the stairs. Great job, Osimo. Well done. And of course, it takes even more balance and precision to make it back down, continuously adjusting itself as necessary all the way down. Very impressive, Osimo. Now, we will see more of the lower body improvements in just a few minutes, but first we would like to demonstrate some vital new technology in Osimo's manual dexterity. To begin with, significant changes have been made to the technology in Osimo's hands. With the new premium Osimo version 3, in order to operate 5 fingers independently, the degrees of freedom at the hands have been increased from 2 to 13 for each hand, resulting in 57 for the whole body, which is a big increase over the 34 degrees of freedom in the previous version. Before, Osimo could walk, but would then need to stop briefly before starting to run. Osimo can now move seamlessly from walking to running and can run at 2 different speeds, as we will see today. Innovations in mobility took place over many editions of Osimo, and Honda engineers conducted extensive studies of the human walking motion to determine the best way for Osimo to walk. And eventually, in a groundbreaking innovation, Osimo was able to run. But today, what Osimo does best is walking and navigating our world with ease. In fact, due to continued innovation and advancements, Osimo can even run. But more about that later. Osimo can sidestep continuously, on a curve, or in a straight line, which could be. And further innovations and advances in technology and engineering have enabled Osimo to run even faster, up to 9 kilometers per hour, which is the equivalent of a fast jog for a human. Now, at that pace, Osimo would run a mile in about 11 minutes. Osimo, are you ready to run again? This time, even faster.
I am ready.
Okay, on your mark, get set, go! Great job, Osimo. Very impressive. Now, in order for Osimo to run, it had to be able to repeat the movements of pushing. Good job, Osimo. In addition, it can now maintain its balance against the reaction force from kicking the ball. Osimo, are you ready for a game of soccer?
Yes, I am ready.
Okay then, let's show everyone what you can do. Oh, goal! Good job, Osimo. Now, as we mentioned earlier, our dream is that also dance. This is an example of the fluidity of Osimo's motion and movements. Well, Osimo, why don't don't you show everyone what you can do?
I will be glad to.
Okay then. Osimo, hit it! Come on, everybody.
Yeah. This is a longer video, right? Yeah, okay, and then we have the robots by DLR, right? This robot, this is from the German aerospace. Yeah, there are two humanoid robots at DLR. So this one was what they call David, and the other is this Justin. This one.
David seems to be more like robust.
Sorry?
Like David seems to be more like robust with more like force capability.
Yeah, we can check the what particular applications they are suitable for, both of these.
On the Roland Justin robotic platform, we test different ways to operate assistance robots from a distance. This technology can also be useful for taking care of patients with highly infectious diseases or who are in quarantine. In the use case shown in this video, the humanoid assistance robot Roland Justin provides support for senior citizens and for people with moderate restrictions in mobility, helping them to live safely and independently within their own four walls. Across the world, people are living longer. 20% of the people living in Germany are past retirement age, and this portion of the population is increasing. Users of an assistance robot such as Justin can rely on the help and support of friends, relatives, or carers, who can access and control the robot over familiar interfaces such as a smartphone or a tablet. They can also receive professional help from doctors or nurses via direct teleoperation from a control center. The task demonstrated here by researcher Michael Panzersch is to fetch a glucose injector from a drawer and to simulate administering an injection to the patient on the sofa. While many motions can be automated, such as opening the drawer and picking out the injector, others are more difficult or even unsafe to automate. In this demonstration, the operator first uses an intuitive tablet interface to retrieve the injector from the drawer. In structured environments, such as the kitchen area here, Justin can use his knowledge management system to recognize objects in his field of view and present the operator with possible actions related to these objects. To administer the injection, however, the operator teleoperates Justin directly through the Hug haptic device. The operator's head movement is tracked, allowing him to look around Justin's environment. By moving his own hands and arms, he can move those of Justin, and he also feels the forces that Justin feels. In this way, he feels present in Justin's environment. This kind of haptic teleoperation can also be used to command the other robotic systems at our institute. The two modes of teleoperation presented are suited to different tasks. At the Institute of Robotics and Mechatronics of the German Aerospace Center, we are interested in how to combine these ways of operating Justin to make him the optimal robotic avatar, and also in exploring the limits of what is possible in teleoperation. These kind of teleoperation procedures can be a baseline against which to test upcoming artificial intelligence solutions in these scenarios. Assistance robotics is the core of the research project SMILE. The vision of the SMILE project is to help people with restricted mobility or physical disabilities to enjoy more fulfilling and independent lives. To check out all the research we have going on at our institute, click the links in the
So there's another one actually also.
Control applications of Toro, a torque-controlled humanoid robot. The self-contained robot Toro was developed as a research platform for walking and whole-body control. It has a total of 39 degrees of freedom and can be operated both in position and torque control modes. Here, the highly sensitive inner loop joint torque control is demonstrated with an impedance controller for the whole body. The walking controller is based on the divergent component of motion, also known as capture point. The high-level walking commands for the robot can be autonomously generated or can be introduced via proportional velocity input using the remote control of a gaming console. Footstep locations define reference trajectories for the DCM, which correspond to ZMP trajectories on the robot feet. These trajectories are tracked with a feedback control. Note that Toro pulls the safety crane, which acts as a disturbance for the controller. While walking, the upper body works in impedance mode. The maximum speed that the robot can attain is about 0.5 meters per second. The feet are relatively small with a length of 19 centimeters and width of 9.5 centimeters, which represents a bigger challenge for keeping the overall stability of the system. Based on torque control, different impedance behaviors can be easily realized, as demonstrated here with an energy-based limit cycle controller used in a simple handshaking demonstration. The desired energy level can be manually set to 0, which dissipates the arm oscillation, but the arm will swing up if the energy level is restored. A multi-contact whole-body controller for balancing and posture stabilization is implemented using optimization of contact wrenches, while taking into account frictional restrictions and center of pressure limits. Here, the controller is demonstrated in an application where the robot is balancing on a rocker board. The changes in the slope of the board recreate uncertainties of the supporting terrain. Using the embedded IMU is crucial for tracking the posture of the robot, which allows the controller to maintain the balance even on rough terrain. The controller is also able to cope with a changing number of contacts with the environment. The robot uses the active contacts to maintain the COM position and torso orientation, while the unused end effectors maintain their pose relative to a world frame. Ongoing research is focused on further development of the control strategies, for instance for walking on rough terrain. Also, the integration of egocentric and sensory-based planning and control will lead Toro towards more autonomous behaviors.
Yeah, you can check like the official website. I think they have really, you can find all these projects in the Humanoids 2020. Yeah, maybe I'll add this also in the references, right? Okay, now let's quickly go to the other ones. Yeah, now let's go to the more uncanny valley kind of robots. I think this would be interesting. Has anyone heard of this Geminoid? This, has anyone seen it? You probably have seen it on YouTube or something. How many of you know about this?
I've seen like small clips, but no more.
Yeah. So I guess this one, I'm looking for smaller clip. Yeah, let's see here what they have.
We're always adjusting something. What are you doing? コーダー喋らへんのか。ちっちゃい。音は小さい。音ちっちゃいと。いやそれ OK. So let's have more natural conversation. Natural conversation. We always adjust with the... They were twins, so we have a twins. Yeah. This is warmer. Your hand is warm. It's from the...
cold.
Cold. Very cold.
Very cold.
Very cold. This is like a crazy tea party.
Maybe some other videos. Yeah, I think these are more of the creepy ones. You can actually check the research that they have in the lab, right? Ishiguro lab. Yeah, they have you can check the publications, the robots, projects. The Geminoid is just one, and they have a lot of other projects on the human robot interaction, reinforcement learning, all these kinds of things. And then publications, so do robots facilitate life review narratives of more on the social robots and human robot interaction side. So yeah, this link is also there in that, so you can check it out. And okay, let's see, Aibo is let's Astrobot. I don't remember which one this was. And Sophia, we have probably seen a lot of this, so we don't need to see it again. Astrobot, let me see which one this was actually. It's more, I guess, I don't know if this is an actual robot or is it just a character from a movie. Maybe I just accidentally added it. But this one, QRIO, this one is this one is a bit older one, similar to those, the now robot ones.
Question over here. Where in Sony do you come from? Sony.
Yeah, so this one would be it, and the Abo, this one is the robot dog by Sony again, right?
It's surprisingly animated. There are so many little actuators in here. Hey, man. Yeah. What's happening? Hey, good boy. Oh, good boy, man. This is weird. This is good. Is that, oh, you like that? Look, he likes it when I did that. Ibo, sit. Oh, good boy. Did you see that right there, Jack? Shake hands. Oh, hey. Bang.
Yeah, I guess, just wanted to add this also because it's the same, it's also from Sony, so this one also I added there, but I guess it makes sense to talk about this in a quadruped theme that we might have in the future. And then the Toyota robot. Let's see. Yeah. So this can be. Yeah, let's see. Kirobo Minia. I guess you are also familiar with this. So let's watch these two ones, and then we can talk about this GitHub repository which I found, and also other resources that might be interesting.
Introducing THR3, Toyota's third-generation humanoid robot, designed and developed to explore how torque servo module technology can improve joint control, whole body coordination, and real remote manipulation. The torque servo modules in the robot's joints enable highly flexible movement, so it can perform complex actions smoothly, and the system assures stable, balanced, safe, and reliable movement.
THR3 was designed with Toyota and partner robots' vision for mobility for all. Our aim is to help society by creating friendly and helpful robots that can coexist with people and support them in their daily lives.
THR3 is controlled by a master maneuvering system, which connects the operator to the robot via 16 super-sensitive torque servo modules in the chair, motion and force sensors in the feet, and 29 torque servo modules in the robot's joints. This intuitive and synchronized remote control system enables the operator to accurately and instantly manipulate the robot's motion. Plus, the head mount display connected to the cameras built into the robot enables the operator to see what the robot can see in 3D and real time. Together with the torque servo modules, this technology lets the operator direct the robot's movements and the force it exerts into its actions.
This robot was created to test our latest technologies. In the future, we will build up on these technologies to create robots that can assist anyone facing mobility challenge. Our goal is to provide ever better mobility for all, whether someone is traveling across town, across the country, or across the room.
These new technologies will help to transform our robots into partners. They will not simply be useful, they will also be fun and friendly. THR3 is the next step on our journey.
Yeah, so this would be another one, and actually there are a few GitHub repositories that you can also check out. So this one that I found, if you have a 3D printer, I guess this is an open source project that can be interesting, but at the same time, I guess there's you could play around with simulation as well, right, in simulation environment. So all of GitHub. Yeah, this was the main project, and then you can check on GitHub. You can find some good repositories. I think this one, Open Humanoids. Yeah, this one also I saw. Yeah. Yeah, so I'll sort this, and I'll also add a link to more repositories in the PPT, and I'll share it. So yeah, we can conclude today's session as well. So yeah, has any one of you done any project in this domain or similar to what we did today?
I haven't.
Yeah. It's also because of the hardware restrictions. It's also tricky, right? So
Yeah, hi Chandandeep, Pranshu here.
Hi Pranchu, good
Yeah,
to see
hi.
you. How are you?
Thanks. I'm doing great. So I recently joined this session. I was not aware about the meeting that was going to happen, but yeah, I have worked on humanoid robots. There are a couple of them that one I made as in my university project, and another one we worked for a Mexican client. So the university project that we did, we started it in the first year of our undergrad. It was named as Disha, and it was in the year 2017. And I guess that was a time when there was no humanoid robots apart from Asimov. Asimov by Honda.
Yeah. Oh,
Because
so a
even
while
Sophia
back.
was, yeah, even Sophia was released in the like September 2017,
Hmm.
and we started it in the May 2017. So it was before Sophia. So I will try to find out if I have some pictures or videos of it by then. If like I have a couple, like we did simulation, we did hardware, we did like voice recognition, like object recognition, and a lot of things.
Mm-hmm.
And the Mexican client that we worked for, it was robot that could be used in malls. So I would be showing you some videos. I will search for it. Until then, if others have anything to share, they can share.
Yeah, for sure. Yeah, thanks for pointing that out. Uh, yeah, and let me see. Yeah. Okay. Let's have a small introduction session as well, right? So I think Pranshu, you're joining for the first time, so maybe we can start with you, right? Generally, what we do is after the session we have a small introduction and getting to know each other.
Okay. So, thanks for the first thing, like inviting me. And hello everyone, I'm Pranshu Tople. I've done my BTech in mechatronics. I graduated in the year 2020, and after that I started my own company, which is Rigbetter Labs. But even when I was in college, I used to work as freelancers for various different companies, and we used to take projects like service-based projects for various national as well as international clients. So I've been working into this industry for past 3 years now,
Oh
and
wow.
that was yeah, and that was the reason I like right after my graduation I started my own company. I had a lot of industrial connects during those years. Apart from that, I also have my own YouTube channel where I post things related to ROS, couple of tutorials here and there about some open source packages. So
What's the
yeah,
name of the channel?
you can
I
just
think I've seen your channel, but what's the name? Is it with your name or?
it's my name. You can search Pranshu Tople. Yeah, there you go.
Yeah.
Yeah. So I've made videos on like quadruped robots, some Mars rovers, also some navigation based robots. So I guess most of you guys must be knowing James Bruton. He is really active in robotics community, and
Yeah.
he made ROS based robot. So I've been working with him for simulation of his robot, because again the same thing. Not a lot of people can afford making those robots. So
Yeah.
if you go on to my channel, I have made simulation for his robot. So there
So
you can
this
see
one, no, this
one
is the Spot Mini one. Okay.
the first two like the ones in the right hand side, a second row,
Yeah.
second.
This one.
Yes, this one.
Okay. So how are you? So you're working with James Bruton.
Yes.
Oh, how? I mean, so you're helping it. So he is making these 3D printed robots, right? And you're making the simulation environments for these robots.
Yes, exactly. So even if you go onto his GitHub repository for this robot, you can see me there as a contributor because I'm contributing to the simulated environments.
Oh.
So it's github.com/xrobots.
github.com/xrobots.
Yes.
So did you reach out to him, or did you just started contributing to his open source project?
No, we first started talking on Instagram, but then I directly contributed. So our bond even become closer then.
Oh, that's
So
really cool.
really useful robot, which is the third repository, first column.
This one?
Third repository. No, below that.
Okay,
Really
third, yeah, really useful robot.
Yeah, so I've been working with him on this. So this complete documentation
this is your is made. Wow, that's really cool. So this is a robot that he made in okay. Yeah, I think we also saw this robot, right?
You can go into the videos, and if you scroll down a little bit, yeah, there is the one.
This one.
Yeah.
So you are making the URDF files and everything of this,
exactly.
and XML and URDF files.
Yes. Yes.
It's really nice.
So that is all I do. I love sharing my things, whatever I learn. So that is the reason even I have a YouTube channel.
Yeah, that's really I think helpful, and you have a lot of videos here. So designing how to design. So it's I think a lot of you give like overview from scratch basically. So for beginners, it's really suitable, right? Your videos.
Exactly.
Yeah.
So I have explained all these things, how you can make the most out of the open source community, how you can get onto the free designs, and then how you can use it for your purpose. So I've even defined those things.
Yeah, that's really cool. So this is the one where you made the whole thing.
Yes.
So you made it in which software? Which CAD software did you use?
Fusion 360, Autodesk Fusion 360.
Autodesk Fusion 360, and then you converted those STL files or whichever you used to the URDF format, right? And you wrote the code.
Yes.
You wrote the URDF file.
No, it's not that way. Actually, there is a package called as Fusion to URDF. So if you design it in Fusion 360, you can directly convert it.
Oh, that's good. That's good.
Yeah, so I've even explained that in the live streams, because I usually do live stream because I don't get time to edit videos usually. So whenever I'm free for an hour or two, I just do YouTube live streams where I respond to questions and also show them how it actually works.
Yeah,
so
that's really interesting. Yeah, and also we are in talks of having you as a speaker on our meetups as well, right? I think it would be very helpful to all of us as well.
Yeah. May I share my screen? I have a video to show you about the Disha robot that I said.
Yeah, sure. Go ahead.
Yeah. Can you see my screen?
Yes. Now we can see your screen.
Yeah. So this was the robot that we made. So it was made out of a mannequin, so that there was no 3D printing cost and anything extra.
Yeah.
But we added servo motors inside it. We added the controller boards. So this was the bare minimum thing. So you can see there was a top torso, and the reason behind making it a girl was we cannot make legs at that part. Like when we made this, we were in the first year of engineering.
Oh wow!
So we wanted to have wheels at the bottom, and having a boy like a man kind of figure having such wheels would look good. So that was the reason to add to add wheels. We made it like a skirt. So it had features.
Very creative, right?
Yeah. So we added a Kinect, so it was able to detect human beings.
Mm-hmm.
So depending upon that, it used to understand what the person is doing. Is he thinking? What is he waving hands? It also had a camera, so it used to recognize people. So here you can.
That's really interesting. You did it in the first year of your bachelor's, right?
Yes, we did it in first year. And then there was face recognition, there was object tracking.
That's really
nice. This was all running on Raspberry Pi because that was the time when Jetson was also not released.
Yeah.
But later on, we when we graduated in the final year of engineering, we added Jetson to it, so it was more smooth. We added simulation support. So I am not able to find the simulation video, but maybe next time I will show you, or maybe I can upload it on the Discord server so everyone can see it.
Yeah,
So we
yeah.
made simulations in which the robot can navigate around the room
Hmm.
and can pick up things. We added like all the joints were supported by Move It. So if I say go to kitchen and bring me a bottle of water, so it used to first go like it used to recognize my voice commands. It used to then navigate to kitchen, find for bottle. Once it finds bottle, it will get the post destination. Then it will go there and pick up the bottle.
Oh,
So it used to do all the inverse kinematics calculation on its own.
That's really interesting. And you also made it low cost, right? How much did
Yes.
the overall thing cost you?
So the overall thing costed us around like 1500 or 2000 US dollars. That was the
Oh,
total cost.
okay.
Yeah.
And yeah, that's pretty like cheap for a humanoid robot,
Yeah.
right? And you also
Yeah.
had 3D depth cameras as well, and yeah.
Yes. So again, that was a time when there was no Intel RealSense. So
Yeah,
we
yeah.
used Xbox Kinect, which we scrapped from a second-hand market. So
Wow.
we got it at a very cheap price.
That's really,
So
really creative, man. I mean, yeah, you made use of whatever you had available and you built this. So, how did you learn all these things? You learned on all of these on your own? Because in
yes, yes, yes.
universities,
Yeah.
they wouldn't teach you this, right? I think.
No, it was on our own. So what was happening like after first year of engineering, we wanted to learn something of our own. We don't wanted to go to home for vacation. So that was a time when we said to our university, just let us use your resources. So this was the some photos while making the robot. So we just asked them like, can we use your resources and we will stay in university and make this. So they liked the idea. So, and even when we were in our engineering, we used to participate in various robotics competitions. So that is how we managed our own funds because we won most of the robotics competitions. So we saved it so that we can invest it into this robot.
Oh wow, that's really nice. And you're originally from Pune, right?
Yeah, I'm original. So
Okay.
like my hometown is Nasik, which is like around 200 kilometers from Pune. But right
Yeah.
now I stay in Pune due to work purposes and everything.
So you're currently also in Pune. Okay.
Yes, right.
Yeah.
So this was the robot. So even we wanted to add animatronics. We also made an animatronics head, but we didn't get time to integrate into this humanoid robot. So if you go onto my Instagram, I can show you. I have a video of animatronic head as well, which I made. Yes, there you go. So even this was made in November 2017. So we wanted to integrate this into our robot, but it didn't happen.
Oh.
So here, so it had all the motions of eyes, eyebrows.
Yeah. Like the
So
eye
it
cup
had,
that we saw, the eyes are like that, yeah.
yes, yeah. So there were total 13 servo motors in the head, micro servo motors, and they
Oh.
gave it, yeah.
So what's the mechanism behind the eyes? Like, is it a 3D joint you're using, or what sort of an arrangement is that?
So it was like this complete robot was laser cut on a MDF sheet, and there was no 3D joints or something like that. We just what we say, these ball caps that you can see are ping pong balls. Okay.
Oh.
And then we were controlling it using what we say, paper clips. So we unfolded those paper clips, we attached it to the servo motor, and it was pushing the eyelids up and down. So that was how it was working.
Oh wow, it looks really sophisticated, and you used also here you used what was available to you.
Yeah, exactly.
Yeah. So it just shows that you can make things even with what you have, which is really amazing.
Yeah.
And this is a cardboard based as well, right? This is or is it
MDF.
wooden?
It's wood.
Wood.
MDF.
Okay. Yeah.
Yeah. And even I guess I have some more photos of behind the scenes of this robot. I'm not sure if it will be available here or not. Yeah, so while making Disha, the humanoid robot, I have photos.
Nice.
Yeah, so this was the robot. We revived it a year later and then we worked on the AI part. So here we had a microphone, camera, and speakers. Everything was running on Raspberry Pi. So we added face recognitions.
Wow, that's
Yeah. So here, if we show it a mug, and if I ask what is this, so it says it's a mug. So then even
Yeah.
recognize logo. So if I ask what logo is this, it used to say it is a Raspberry Pi logo. Then it used to read text. So even if you give it a newspaper, so these OCR and all these things are common now, but we added that in 2017.
Yeah, makes
Then
sense.
the second version of Disha had a 3D printed arm. So first version was made out of a mannequin. This is the second version now. So it had more joints and stuff. And this is when we started getting into ROS. So we add, like as you said, we made the complete URDFs from scratch for Disha.
Oh wow.
And yes. So here was it.
And did you take like online courses to teach yourself computer vision and learn these OpenCV packages?
No, it's completely available on internet for free. No course. I used to like whenever I had a task, like if I want to make Disha recognize something, I used to break it. Okay, so first is like I want to access camera. Second is I want to get the repository. So I used to break down these parts, and then I used to search for specific resources.
Yeah.
Then,
so learning along the way, right?
Yes, exactly. So these were the motors in the hand. So now it was able to control each joint individually. Then this was the RVs. If anyone knows ROS over here, so this is the RV. Then I guess, yeah.
And how long did it take you to build, let's say, the first prototype of
The first prototype was made in 2 or 3 months, I guess.
Okay.
But later, yeah. So that was the first prototype. Then we didn't work for it for years, and then we again revived it in our final year project. So
okay, so first year and last year then you built. So this 2.0 is in the final year, right?
Yes. So between that we were training ourselves. So between that we were learning computer vision, we were learning ROS. So we did a little small projects in between. So so this was one of the motion, like we were completed one arm. This is the ROS simulation. Yeah, there you go.
Really interesting.
Yeah. So this was complete Fusion 360 design that we were making. And I guess, yeah. And as you said, what did you do in these middle years? So I will just show it. Yeah. So we learned computer vision using small projects. So this was one of them, which was a robot, like simple robot with some motors, camera, and it used to recognize shapes.
Oh, wow.
So once I showed it a shape, so it was a circle shape. Here you can see the robot is watching, and then there were 4 shapes on 4 different walls. So it used to find where is the circle again. So it used to look at the, once it finds circle, then it used to go over there.
And here you are using a kit for the hardware.
What?
Are you using a robot kit for the hardware, or you also built this from?
No. This is completely our own build. Like it's not a hardware kit. We 3D printed.
3D printed it. Okay, nice.
Yeah. So the first model, you can see these were made of foam board. So this was just the basic test. Later we 3D printed the complete thing. So we were not patient enough to like let it 3D print and then make it. So we just made it. And so even this was the first version. You can see it is a very basic thing.
Wow.
So we are showing it triangle. If you remove triangle, now it will try to find triangle.
Yeah. You did a lot of projects during the college, right?
Yeah. So there you go. So these were the projects. Then again, we did a couple of augmented reality, virtual reality projects to understand locomotion. We made these small biped robots as well.
Oh. That's interesting. So this concept also you came up with your own, that it should be like the design of it, or was it inspired from somewhere?
No. This project is inspired by another open source project called as Otto.
Oh, really?
DIY.
Okay.
Yeah, you can go to this page. So they have similar kind of robots. There
Oh
you go.
wow.
Yes. But again, we just got inspired and we tried to make our own out of it.
Yeah, and you probably so they are using they're using 3D printed parts or
Yes. Yes,
yeah.
this is 3D printed. Yeah, so this complete project is uh, like open source. So you can get 3D printed parts, you can get laser cutted parts. They have a pretty nice website as well. So if you go over here, they even have this what Scratch programming support, Arduino support, a lot of things. And nowadays people are like making it. So this is now a wheel robot as well. So if you flap the
Oh.
yeah, so now it can move like wheels. So this
So
is a very
it's that's a really unique design, right?
yeah.
It can be wheeled as well as it can walk.
Yes.
Really
So
fascinating
yeah.
stuff.
So we got inspired from them, and then we made our own version of it. Then some again these kind of robots where it was by hexapod.
Hexapod, yeah.
Yes, but using just 3 servo motors. So again, price was a big factor when you are in India. So we tried to make a hexapod with just 3 servos.
Wow.
So these are a couple of projects.
That's really inspiring, and what is amazing is also that you made use of whatever you had, and you still built interesting projects.
Yeah. Even this was one other project where which brushed up my computer vision skills. So we made a rock-paper-scissor robot which always wins. So whenever you make a paper, it will make the scissor mechanism. So
okay.
Yeah.
Oh.
So there was camera which was able to recognize what shape you are making, and then it used
So
to make
this is also in college, right? That you did.
Yes, everything is in college.
I mean, it's pretty insane. I mean, in 4 years, how did you manage to do all these projects, right? I mean, you had academics and all as well, right?
Yeah, my academics was not so good. So you can guess like I got 8.2 CGPA was my final CGPA.
That's good. That's good, right?
Not from a private engineering college. Usually people expect it above 9 point something.
Okay,
But yeah.
okay. But you did more interesting stuff, so
Yeah. So here you can see it was from this was from May 2017. So this was some basic things like we added it motion. So it had omni wheel, so it can move sideways as well.
Nice. So the wheels can move sideways. Yeah, that's nice.
Yes. Then we also
how did you buy those wheels? Where did you buy those wheels from? Is it easily available or?
Yes, it is available. So this company, it's an Indian brand, so they have a lot of robot parts available, and it is at very cheap prices over here compared to other things. So if you search for Omni wheels, you will get over here.
Yes.
It's robu.in. So they have small ones as well. We used a little bigger ones. I guess these were the ones that we used. So you can see it's for like 3,000 rupees each. So if you are getting for like 4, then it will be around 12,000 rupees.
Yeah.
So this is the project that we did. So I just wanted to share it because you asked like what else are you doing with like this humanoid robot. So this is one I made.
Yeah, that's really interesting stuff, and also thanks for sharing these websites, right? Robo.in. I didn't know about this before, so I think it would also be because also on our server people try to do these projects, and I think it would be helpful for them as well.
Robo.in is the best website I can recommend is because they have every part that you need for robotics thing. So there is nothing that you won't get on robo.in. So definitely check it out.
Really amazing. Yeah, thanks for stopping by, Pranchu, and also for sharing these amazing things. And we will also talk in our meeting that we have to schedule, right? So yeah. And the theme for this month is actually humanoid robots. So what we did today was we were just exploring different types of robots. So this is a more casual and more top level thing, and then we go deeper with every session. So next time we will take a case study of one of the robots, and then after that we will take one particular part of that product, let's say Atlas from Boston Dynamics or something, and then we will discuss that thing, and then so on. That's the idea, and would be cool to see you again in the coming sessions.
Sure. I have just found my research paper as well. I would show it to you. This was like the first half of the research paper. So can you see my screen? Yeah. Yeah. So we started with this Fusion 360 design. Here you can see. Then we added all the joints. And this was the ROS simulation part where we were making a environment kind of thing in Gazebo. And then we did mapping using G mapping. And then there was a simulation of inverse kinematics. Then there was fabrication process. That time we used Jetson Nano and Tinsy.
That's nice. That's well documented, like from start to the end, right?
Yes. And even we for higher torque we used gear reductions. Then we used bevel gears as well. So where there was size constraints, we used bevel gears like this. This was up and down motion. And then this was for the navigation part. So once we give it a goal, then it used to plan its own path and it used to navigate over there. And if in that case, and then this was the inverse kinematics, like position of the robot arm.
Oh wow, that's like This is everything from scratch. Even the whole robot and mapping everything. So that's I can see how much you also learned using during this project, right?
Yeah.
Awesome. So this is like the documentation of this, or is it a paper that you published?
No, we didn't publish it. We were in talks with some companies for filing a patent, but that didn't go forward. Then COVID happened, and then we didn't get time to publish it or anything. So it's still unpublished. This was just a progress paper that we shared with our university, showing the of the robot. So I just got it into my mail, so I shared it with you guys.
Yeah. Okay. Perfect. Yeah. I'm also curious to know about what you're doing at your current startup, right?
Yeah. So currently, what we do is we are a service-based company based out of India, but the major advantage of being based out of India is a lot of foreign clients don't want to invest a lot of money in robotic research. So they invest into Indian-based companies where the cost per the capita income is low. So in India, staying in India, we serve for a lot of international clients. We have companies from USA. The two major companies that we deal with is Black Eye Robotics, for which we make robot arm based softwares. So we use MoveIt for them for motion planning of robot arms and sensor fusion. So they have a warehouse robot along with a robot arm over it. So they are based upon what order you get. We go to a specific point in the warehouse and then we take that box and we pack it. So this complete process is automated. So Boston Dynamics recently released their robot Stretch. Have you seen that? Can you share your screen and just search for it? It is a big robot base with a robot arm on top. So it is similar kind of robot. So it can be basically a competition for Boston Dynamics. So it's another Boston based company, which is Black Eye Robotics. So we make software for them. Apart from that, there is one more New York based company, which is Apsara Energy LLC. So we work on research robots with them. And one of the commercial client that we have is the Mexican client called as Octopi. So they make robots that can be used in malls. So in malls, what happen is, let's consider if you want to buy shoes. So you can just go to the robot and tell me you want to buy shoes. So the robot will recommend, like, you can go to Nike store, you can go to Adidas store, and it will navigate you through the mall. It will guide you through the mall and take you to the stores where you can buy those things. And if and there is also a lot of economy into it, because let's consider if Nike is paying the mall more to advertise them, so the robot will try to convince you to take to the Nike store. So sometimes yeah, so even that happens a lot. So based upon which company is paying you how much, and let's consider if there is some McDonald's paid you extra. So while going to the Adidas store, the robot will say, "Are you hungry? Let's have something at McDonald's." So even that is there. So we use a lot of natural language processing over there. Again, we work on robot simulations and prototyping. So the prototypes is being like, we make small prototypes over here in India, and we work on the large scale simulation. And based upon the findings from that two options, we tell it to the companies that are overseas, and they manufacture at their end. This is how it happens.
Really cool, man. Really cool. Yeah. So this was a stretch video that from Boston Dynamics. I saw that. Really nice.
So we have the Boston-based company, which is Black Eye Robotics. So even we are working for a similar kind of robot for them.
And for cardboard picking, right?
Yes, for like complete warehouse management. So it
complete
can be
warehouse. Okay. Black Eye Robotics, is it correct or?
Just a minute. Black Eye, just an eye, like iPhone.
Black Eye.
Yes, robotics. That's right. Yeah.
Okay.
So they are majorly into these parts, like military robots, but right now they are also working.
This one, right?
Yes,
Black Eye.
right.
Black Eye. Okay. Nice.
Yeah. This is the robot arm that we are working on. So I guess this.
By the way, like so this is this, like, we record our sessions as well. Is it okay that this is being recorded?
Yeah.
Or okay?
Yeah. Sure. It's available on internet, so it's okay.
Hi, I'm Aiden Bustani.
Yeah.
I'm here to show
So
you.
This was the initial robot when it was stationary. Now it is like moving on a wheeled robot as well.
That's a variety of different projects that you're involved in. Awesome, man. Yeah. Thanks for sharing.
Yeah, my pleasure.
This and sorry.
They have a couple of defense related cool robots as well. You can go into the defense side. Yeah. Oh, they don't have the photos of robots. Okay. So even they have made some. You can search on Google Images. There are a couple of images by them. If you search Black Eye Robotics on Google, yeah, the first robot you can see over there. Yes, these robots. Yes, this one.
This one, right?
Yeah. So they are into this market since very long.
Yeah, this is an old video. Really nice, man.
So these robots were majorly manual controlled at that time. So the things that we're working on is basically upon making them autonomous, making them adaptive to the environment. Yeah, so they are more like a self-aware robots.
Okay, yeah, that's pretty interesting. Yeah. Thanks, Pranchu. We'll talk about this and how to plan the session and details of it in our individual conversation as well, right?
Yeah,
So,
sure.
and maybe let's hear from the other guys. So, I mean, you're new to the server, so maybe it will help you if others also introduce themselves a bit. So let's go to Juan Diego. Can you shortly tell about yourself?
Yeah, sure. Hello, guys. By the way, it was really amazing what you did, Pranshu. And my name is Juan Diego. I'm from Colombia. I am a mechanical engineer. Right now, I'm doing my master in Spain about robotics. And basically, yeah, I'm also interested about those topics, just as you guys.
Perfect introduction, right? Yeah, thanks, Jan. And Dennis.
What?
Can you give a short introduction of where you're from, and you can also talk about what the cleaning robot project that you are working on. Yeah, just a short introduction.
I'm building a robot vacuum cleaner with ESP32. Now I will send a photo.
Yeah, I think yeah, you don't need to send. I think it's on the chat room, so I'll just open it here, right? My screen is still shared, right? Yeah. So yeah, this is the robot vacuum cleaner that Dennis is building. And there was another one, this one, right? So yeah, yeah. At some point, he will also be sharing his project. So he's still in the process of it. He's progressing very quickly on that. So
Dennis, I have a question for you. Like even I was thinking to make a similar project because we have the navigation stack ready for the robot. So we were thinking to buy a vacuum cleaner and just attach it over it. So I just wanted to know about the vacuum cleaning capacity of the robot base that you are using. Is it like how does it vacuum? Does it clean the room or it doesn't? I was curious about that.
I didn't understand your question.
I want to ask, is the vacuum of the robot powerful enough to suck the dust on the floor? Because the robots that I have seen are not powerful enough to clean the dust. How are you working on that? Chandandeep, can you explain my question in simpler words to Dennis?
Yeah, so what Pranchu is asking is the vacuum mechanism powerful enough to suck the dust, because Pranchu says that the vacuum generally might not be doing the cleaning process very well.
I create this robot vacuum cleaner for test my algorithm, not for cleaning the room. I want to test my algorithm.
Okay. Yeah, I think he's using it as a way to try out different algorithms and learn using it. So he's not looking to build to clean his room basically, right? I think so. Yeah.
Okay.
Yeah. And I think Shore and Ismail, I think they also can't hear us, so unfortunately we can't have their introduction. But yeah, thanks a lot guys for joining, and it was really amazing discussion today. And also Pranshu just dropped by and shared his really exciting projects, which was really cool for all of us to see. And so next time we'll take up one case study. I'll actually check which of the humanoid robots we have good content online, and so I'll make an announcement of what the theme for the next meetup would be. And by the way, the timings are like we meet every week on Sundays at 11 a.m. CET, and that would be 3:30 p.m. Indian Standard Time as well. And I think Yuan and Dennis, you can convert it to your time zones. You know the times, right? So yeah, that would be it. So yeah, thanks again for joining, and see you guys next time.
See you guys. Bye.
Bye.